What is going on, everybody? It's Medicosis Perfectionalis. Welcome back to my statistics playlist. In previous videos, we had an introduction to statistics. We talked about data, samples, populations, parameters, and variables, such as independent variables and dependent variables, explanatory variables and response variables, quantitative variables and qualitative variables, numerical variables and categorical variables, discrete variables, continuous variables, ordinal variables, and nominal variables. We talked about different methods of data visualization, such as the bar chart, the pie chart, the dot plot, the scatter plot, the heat maps, the tree maps, the stem and leaf plot, as well as the box and whisker plot. After this, we talked about the normal distribution curves, the measures of central tendency, such as the mean, the median, and the mode. And today, we're talking about the measures of spread, also known as the measures of dispersion, the measures of scatter, or measures of variability. Please don't forget that the standard deviation is the square root of variance. Put differently, variance is the square of the standard deviation. Click the like button, click the subscribe button, and let's get started. This is my statistics playlist. Please watch these videos in order to boost the probability of understanding. In statistics, we have measures of central tendency and measures of dispersion, or measures of spread or scatter or variability. The measures of central tendency include the mean, the median, and the mode. Oh, by the way, the mean has many types, including but not limited to the arithmetic mean, the geometric mean, and the harmonic mean. And there are many others. In most cases, when we say the mean, we mean the arithmetic mean. What does that even mean? It means the average. The median is the middle value, and the mode is a la mode, i.e. the most frequent or the most trendy value. As for the measures of dispersion, we have the range, the interquartile range, the variance, the standard deviation, which is the square root of the variance, and something called the mean absolute deviation, or MAD, which drives most students absolutely nuts. What is the range? It's the maximum value minus the minimum value. How about the interquartile range? It's the third quartile minus the first quartile. To learn about quartiles, I have a separate video in this playlist that is titled Quartiles. Next is variance, which is the average squared deviations of each data point from the mean. But here's the problem with variance. Variance is weird. Why is this? Because let's imagine that we are measuring the length of something. Of course, as you know, the length should be measured in meters. Okay, but if you square meters, what do you get? I get meters squared, like this. Now, is meters squared a unit for measuring length? No, it's not a unit for measuring length. It's a unit for measuring area, which is totally different from length. That's why the variance is weird, because it gives you weird units that do not mimic reality. So what should we do? Well, it's a Scooby-Doo mystery. How do you get rid of the square? Well, how about you square root it to get back the meter? And this is what the standard deviation is achieving. It's finding the square root of the variance to get rid of this abnormal unit and to go back to the normal measuring unit of length, which is the meter. How about the standard deviation? It's the average distance of data points from the mean. This is a very simplistic definition. And remember that the standard deviation is the square root of variance, so variance is the square of the standard deviation. How about the mean absolute deviation? The word mean means average, not as in why are people so mean. Average of what? Average of absolute difference between each data point and the mean. Next, does anyone remember the normal distribution curve, also known as the bell-shaped curve, otherwise known as the Gaussian curve? Named after the German mathematician Carl Friedrich Gauss. Right smack in the middle, this is the central tendency. What are the measures of central tendency? Mean, median, and mode. As long as this curve is symmetrical, normal distribution, therefore you'll find that the mean and the median and the mode are the exact same value, which is this value right smack in the middle. And the median is always the 50th percentile. Then you can go one standard deviation to the right and one standard deviation to the left. How about another one? Okay, now there are two standard deviations to the right, and this is where you find two standard deviations to the left. Or three standard deviations to the right and three standard deviations to the left. When we say that the median is the 50th percentile, what do we mean by this? We mean that 50% of the data is less than this number and 50% of the data is greater than this number. When I say the 84th percentile, what does that mean? It means that 84% of the data is below this and the rest of the data is above it. When I say this is the 97.7th percentile, it means that 97.7 percentile of data is below it. Here is an important question. Why do we need standard deviations? Why don't we just use percentiles? Because percentiles are easy to understand. When I say the 84th percentile, people understand that this value is greater than 84% of the data. Why bother with a standard deviation in the first place? Let me tell you. Let's suppose that this weird graph looked like a square, like this, alright? Then it wouldn't matter whether you use percentiles or standard deviations, because the difference between the 50th percentile and the 55th percentile will be exactly the same as the difference between the 70th percentile and the 75th percentile, because this is a difference of 5 and this is a difference of 5. However, because the graph is shaped like this, there is a big difference between the middle of the graph and the extremes of the graph. To belabor this point, because it's worth belaboring, let's suppose that this curve represents IQ distribution in a population. And let's say that your IQ is here, which is 2 standard deviations above the mean. Your IQ is about 130. This corresponds to about the 98th percentile, which means that you are smarter than 98% of the population in your country. Now let's say that you have a cousin and your cousin's IQ is 145 instead of 130. This puts your cousin in the 99.9th percentile. So this might mislead you to say something stupid as follows. Hey, I am in the 98th percentile and my cousin is in the 99th percentile. So he's only mildly smarter than me. It's not a big deal. Oh, no. The difference between your cousin and you is similar to the difference between you and someone with an IQ of 115. But wait a second, Medicosis. I'm in the 98th percentile and my cousin is in the 99th percentile. The difference between us is just about approximately 1 percentile. But this 1 percentile at the extreme equals 1 full standard deviation, just like the difference between the median and 1 standard deviation to the right. But I thought that he was just mildly smarter than me. No, he's way smarter than you. It's not even funny. But I'm in the 98th. He's in the 99th. That's the problem of relying on percentiles when the graph is weird like this, when it looks like an inverted bell. The percentiles will be misleading. That's why we need a standard deviation, because the standard deviation is a deviation that has been standardized. The reason why this teeny tiny difference might seem small to you, even though it isn't, is because there are very few people who are that smart. So yes, you are smarter than 98% of people, and he is smarter than 99% of people. But the difference between both of you is huge, similar to the difference between someone with an IQ of 115 and someone with an IQ of 100. And this is the reason behind the asymmetry and the non-congruence between standard deviations and percentiles. Let's say that you're not convinced. Look at this 1 standard deviation difference. The median is the 50th percentile, and this 1 standard deviation is the 84th percentile. 84 minus 50 is 34. So the difference between this point and this point is 34 in terms of percentiles. Now let's look at the difference between you and your cousin. 99.9 minus 97.7 is about 2 1/4. Let's just say 2%. Now see the difference between this and this? If you rely only on percentiles, you will be misled. You will be fooled. Because this looks very tiny, 2%, but this looks huge, 34%. But if you standardize the deviation, this is 1 standard deviation, and this is 1 standard deviation. And let me tell you something. The difference between the 0th percentile and the 1st percentile is infinity. Similarly, the difference between the 99th percentile and the 100th percentile is also infinity. Do not rely on percentiles alone when the curve looks like this. You need to standardize your deviation. In everyday life, people compare heights, so we say that this person is taller than that person. People compare their bananas. Farmers compare their eggs. So we say that this person is taller than the next person, this banana is longer than that banana, and this egg is bigger than that egg. But bigger by how much exactly? Well, the standard deviation gives you a way to express yourself in terms that have been standardized. Because let me tell you something, a 10 centimeter difference in heights among humans is different from a 10 centimeter difference among the length of bananas, which is different from the 10 centimeter difference in the diameter of the egg, which is way different than 10 centimeter difference in the height of elephants. It's the same deviation, but you need to standardize it so that we know your point of reference. And let's say hypothetically that this 10 centimeter difference in height among humans equates to 1 standard deviation. Let me tell you now about the 10 centimeter difference in the size of elephants. It will be way less than 1 standard deviation in terms of elephant length. And that's why statisticians love standard deviations. This concept brings them to an orgasmic bliss. If you wish to see more videos like this in the future, please drop your favorite math emoji in the comments. Let's make it more concrete. Suppose that we are comparing between two dentists. We found that the mean or the average waiting time for patients at dentist A is about 7 minutes and the standard deviation is 5. At the office of dentist B, the mean is 7, the same mean, but the standard deviation is 2. Let's assume that this follows a normal distribution curve and that the distribution is symmetrical. Then you can draw the mean here in the middle, and then 1 standard deviation will be plus 2 minutes, so there is 9. If you go 1 standard deviation below the mean, that will be 7 minus 2 or 5. How about another standard deviation? 9 plus 2 is 11. How about 2 below the mean? 5 minus 2 is 3. How about 3 standard deviations above the mean? 11 plus 2 is 13. And as you know, 3 standard deviations from the mean correspond with the 99th percentile, roughly, which means that 99% of patients are going to wait less than 13 minutes. And only 1% is going to wait longer than 13 minutes. And as you know, since this is a normal distribution, this is the median, which means half of the patients will wait for less than 7 minutes and the other half will wait more than 7 minutes. Now, if we have to compare the shape of this curve to the shape of that curve, how do you think they will look like? Well, both dentists have the same mean. The difference is only in the standard deviation. So let's just draw the mean for dentist A and the mean for dentist B. Dentist A has a bigger standard deviation, so the graph will be more widespread like this. However, dentist B has a narrower standard deviation, so look, you have a narrower curve, just like that, even though the mean is the same, which is 7. This is dentist A with a larger standard deviation, and this is the office of dentist B with a narrower standard deviation. More widespread, less widespread, less concentrated, more concentrated, more variation, less variation. If you wish to download these doozy colorful notes, go to medicosisperfectionalis.com. I help you learn, understand, and pass exams. If you want me to personally tutor you, reach out to me on my website. So this is dentist A and this is dentist B. Pause and review. So when you find that the standard deviation is larger, this means more variation. But when the standard deviation is smaller, this means less variation. How about when the standard deviation is exactly 0? It means there is no variation because all the data points have the same value. For example, 5 and 5 and 5 and 5, 5, 5, 5, 5, 5, everything is 5. There is no variation. The variation is 0. When the standard deviation is larger, the data is more spread out. When the standard deviation is smaller, the points are less spread out. More concentrated, less concentrated. The presence of outliers can widen your standard deviation. Do you remember the shapes of the graphs? This is a symmetrical normal distribution curve. This is a positively skewed curve. Remember, we look at the tail. Forget the hump. Look at the tail. This tail is to the right, so it's a right skewed curve. This tail is to the left, so it's a left skewed curve. If you have symmetrical data, then the standard deviation is very helpful here. But when the data is skewed, whether to the right or to the left, the standard deviation is not gonna be super helpful. If the distribution is skewed like this or this, then it's better to look at the first quartile, the third quartile, and the interquartile range, as well as the minimum value and the maximum value. Remember that we divide statistics into descriptive statistics and inferential statistics. Descriptive statistics will summarize a sample of data, just a sample, not the entire population. From this sample, assuming that you have a representative sample that is randomized, we can infer what the population as a whole is like. Whole here is spelled W-H-O-L-E. Here is an example for you. Can you please pause the video and tell me what is the statistic in this situation? Please pause. Let me tell you, there is reality, i.e. the population as a whole, and there is the sample that we took. Of course, we cannot sample every single individual in the entire country. That would be very difficult, expensive, and time-consuming. What you do is you take a randomized representative sample. We sampled a total of 400 households. We found that 40 out of these 400 are headed by a single male. This gives us a percentage of 10%. 40 divided by 400 multiplied by 100% equals 10%. If you know that the percent here is 10% and that your sample is randomized and representative, we can infer that the numerator is going to be 1/10 of the denominator, just like this numerator is 1/10 of the denominator. What is 1/10 of a million? How about 100,000? Okay, so you put 100,000 here, which also gives you a ratio of 10%. We can call the numerator of the sample data. Also, the individual data points are data, so everything that you collected is data. The 400 households that you interviewed are your sample. The 10% is the statistic if you're talking about the sample. But if you're talking about the population as a whole, the 10% is called parameter. So when we measure the mean, the median, and the mode in a sample, we call them statistics. But when we measure the mean, the median, and the mode in a population, we call them parameters. And this denominator, which is all of the households in the entire country, is called population. And that's why we can calculate the mean for a sample, and we can calculate the mean for a population, and we give them different symbols. The mean of a sample is named X bar, whereas for a population is given the symbol mu. By the same token, there is a standard deviation for the sample and a standard deviation for the population. Standard deviation for the sample is the square root of the variance. And what's the variance? It's the variation between every single data point and the mean. And then after you get the difference, you square them. Why do I square them? Because some of these numbers will be negative, others will be positive. When you square them, you ensure that all of them are going to become positive. Because if you do not square them, they will add up to 0. And if you have 0 in the numerator, the entire ratio will be 0 and you will have nothing. That's why you have to square the difference. You have to square the deviations. And then you sum them up all together. And then you divide by the number of data points minus 1 if you're talking about a sample, but it's just the number of data points without the minus 1 if you're calculating the standard deviation of the population. And then if you just want the variance, you're done. If you want the standard deviation, then you need the square root of the variance. Why do we divide by n minus 1 for the sample and just n for the population? Easy. Because when mathematicians were trying to find the standard deviation of the sample, they realized that they underestimated the actual standard deviation. Oh, how do you increase the ratio? I'm going to increase the ratio by decreasing the denominator. Because if you decrease the denominator, you will increase the ratio, balance this with this, and you will get the actual correct value. How do I decrease the denominator? How about you subtract 1 from the denominator? Oh, that's cool. To get a more accurate estimate of the population. And that's why you subtract 1 in the sample. But there is no need to subtract 1 from the population because the numbers in the population are already accurate because you're counting everybody. Let's practice what we preach. We have test scores for a bunch of students. The first student scored 9 points, the second 6 points, then 5 points, another student 10 points, another 7 points, another 4 points, another 8 points. Please find the total number of data, n, the mean of the sample, the median for the sample, Q1 or the first quartile for the sample, Q3, interquartile range, the variance of the sample, and the standard deviation of the sample. Please pause. What should we do? First things first. Anytime they ask you about median, quartiles, etc., you better rearrange your data from the smallest to largest. Failure to do so is going to cost you an arm and leg, metaphorically speaking. So let's rearrange them from smallest to largest. We start with 4, that's the smallest one, then 5, then 6, then 7, then 8, and then 9, followed by 10. Done. The number of data points, 1, 2, 3, 4, 5, 6, 7. So the size of the data is 7. This is n. How do you find mean? Well, mean of a sample, x bar, equals sigma of all of the values that you have divided by n, which we just found to be 7. So let's add them up together. You have 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 divided by 7. If you add them all up together, you get 49. 49 divided by 7 is 7. The arithmetic mean of this sample is 7, and if you don't like it, pound the mean table. Next is the median. Before I tell you what the median is, let me tell you how to find the position of the median. Not the median itself, but its position. To find the position of the median, you simply take n, add 1 to it, and divide by 2. n in this case is 7. 7 plus 1 is 8 divided by 2. So this is 8 divided by 2 is 4, and this is the position of the median. The position of the median is 4, i.e. the median is the fourth value. Here's the first value, second, third, and fourth. Voila, the median here is also 7. If you find that this method of finding the position of the median to be difficult, then you can find it the good old way with a pencil. All right, what should I do? You cancel something from the right with something from the left. All right, 4 and 10 are going to cancel one another. Then you cancel the 9 with the 5, go to hell. You cancel the 6 with the 8, go to hell. And what is the middle value that's left? 7. That's your median. Next, how to find the first quartile. This is the median, right? Okay, the median divides your data into 2 halves. Look at the first half, all right? The first half has 3 numbers. What is the middle value? Of course, the one in the middle, which is 5. 5 is the first quartile. How about the third quartile? Look at the second half of the data. You have 3 numbers. What is the middle value of these 3 numbers? The one in the middle. So 9 is the third quartile. If you want the more scientific and sophisticated way of finding Q1, we are going to use the following equation. I, which is the index of the rank of the data, is your kth percentile, or k divided by 100, multiplied by n plus 1. Q1 is the same as the 25th percentile, so the value of k is 25. Divide this by 100, multiplied by n, which is 7 plus 1. So this is 0.25 multiplied by 8, or a quarter of 8, which is 2, which means that the rank of the 25th percentile that you want is the second value. What is the second value in this set? This is the first value, this is the second value, so Q1 is 5. You can find Q3 in the same manner, but instead of 25 over 100, you're going to use 75 over 100 because Q3 is the 75th percentile. And that will be 0.75 multiplied by 8, which will give you 6. So the rank of the 75th percentile is the 6th value. This is the first, second, third, fourth, fifth, and 6th, which means Q3 is 9. The interquartile range is always Q3 minus Q1. Q3 here is 9. Q1 is 5, as you see. 9 minus 5 equals 4. Range. The range is the maximum value, 10, minus the minimum value, which is 4. 10 minus 4 equals 6. Next, we need to find the variance, and then the square root of the variance is the standard deviation for the sample. Remember that the variance for a sample is sigma, and then x, which is the singular value, and its difference from the mean, and you divide this by n, because we are in a sample, minus 1. As you know, the mean, or x bar, in this case is 7. So when it comes to 4, what is 4 minus 7? 4 minus the mean. 4 minus 7 is negative 3, so you put negative 3 under the 4. How about the deviation of the 5 from the mean of 7? 5 minus 7 is negative 2. How about the deviation of 6 from the mean? 6 minus 7 equals negative 1. How about the deviation of 7 from the 7? 7 minus 7 is 0. How about the deviation of the 8 from the mean? 8 minus 7 is positive 1. How about 9? 9 minus 7 is positive 2. How about 10 from the mean? 10 minus 7 is positive 3. There you go. What should I do? Should I square them and then add them up? Or should I add them up and then square them? Well, if you add them up, you will find 0. And if you square 0, it is 0. Do not do this. You square them first and then you sum them up. So let's square the negative 3. If you square the negative 3, it becomes 9. Square the negative 2, it becomes positive 4. Square the negative 1, positive 1. Square the 0, 0. Square the positive 1, positive 1. Square the positive 2, positive 4, just like this. Square the positive 3, positive 9, just like this. Now that we have squared them, you sum them up. 9 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9. 9 plus 9 is 18, 4 plus 4 is 8, and 1 plus 1 is 2, and 0 doesn't matter. 18 plus 10 is 28, so the numerator is 28. And what's the denominator, please? N is 7 minus 1 is 6. It is 28 over 6. So the variance here is 28 over 6, which can be simplified into divided by 2 is 4, divided by 2 is 3, 14 divided by 3 equals 4.66666667. This is your variance. And then what if you want the standard deviation? The standard deviation of the sample, which is S, not sigma, is the square root of the variance of the sample, which is the square root of 4.6666666667, which will give you about 2.16. And this is the standard deviation for the mean of this sample. The mean is 7. If you want to go one standard deviation above the mean, you add 2.16 to the 7, so it becomes 9.16. That's the first standard deviation. If you want to add another standard deviation, you add another 2.16, etc., etc. I have a video in this statistics playlist titled Frequency Tables. For example, 2 students scored 3 points each. 1 student scored 4 points. 5 students scored 5 points each. And the score of 6 points was achieved by 2 students, i.e. the frequency of this score is 2. That's why we call them frequency tables. So, given this frequency table, can you find n? Can you find the mean, the median of this sample, Q1, Q3 of the sample, interquartile range, the variance of the sample, and the standard deviation of the sample? Please pause the video. Let me know your answer in the comments. You'll find the answer key in the next video, which will be titled Variance. Take a look at the other videos in this statistics playlist. And to improve the odds of watching more videos in the future, please support this channel. Go to buymeacoffee.com/medicosis. There are more than 700 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine, chemistry, math, and physics make perfect sense.